In this unit, we discuss methods for performing hypothesis testing for 1 and 2 populations when we can't assume normality in the distribution of the populations. This often arises practically in ordinal data, but there are other cases where the normality assumption fails due to the shape of the population distribution. For example, when populations have long tails or cannot take on realizations that are negative. If we can assume normality, we use parametric methods, where parametric generally means that we can assume a distribution. When we can't make a distributional assumption, we use nonparametric methods. Generally speaking, nonparametric methods don't use magnitudes of differences between a sample statistic and a hypothesized population parameter. This is because they assume that a sample statistic can't be calculated. For example, when we have ordinal data, we're not supposed to use operations such as addition and division. Therefore, we're not supposed to calculate the mean of ordinal data. This would render parametric methods useless, because they require the calculation of sample means and sample standard deviations. With nonparametric methods, we have to find an alternative to comparing the magnitudes of sample evidence and hypothesized values. For a single population, we discuss the sign test. With the sign test, we want to know if the population median is similar to some value, tau naught. We take a look at our sample observations, and we count the number of times that observed values lie above and below tau naught. If enough observations lie on one side or the other, we might conclude that the median is indeed something other than tau naught. We use a similar philosophy with 2 populations, where we employed the Wilcoxon rank sum test. In this test, we rank all observations from smallest to largest, then we calculate the sum of the ranks for each population. If one population has a significantly higher sum of ranks than another, then we might conclude that the populations are distributed differently from each other. The idea being that similarly shaped distributions would have a similar sum of ranked observations. There are many different kinds of nonparametric tests. The sign test for 1 population and the Wilcoxon rank sum test for 2 populations are just 2. Though they are both popular, there are others. And you now know enough about how these kinds of tests work to explore other options if you need to. And remember what we said about parametric methods. They are stronger than nonparametric methods. With nonparametric methods, you have to be really convinced that the sample evidence is different from the hypothesized value to reject the null. If you can assume a particular distribution, a parametric technique is always preferred.